Good morning, students. In this lecture, I am going to explain about the standard normal distribution. Okay. So, in the last class, we know what is the normal distribution and what is the density function of the normal distribution and what are the chief characteristics of the normal distribution curve. All those things we discussed. Now we are going to discuss about the standard normal distribution. What is the standard normal distribution? What is the density function for the standard normal distribution? What is the shape of the graph for this normal distribution? Okay, what is the benefit of learning this standard normal distribution? That I am going to explain now. Okay, right. Carefully listen. Actually, there is no difference between the standard normal distribution and the normal distribution. Just one special case of normal distribution is we are calling it as a standard normal distribution. What is the speciality in this standard normal distribution? So, standard normal distribution is a normal distribution with the mean mu is equal to 0 and the standard deviation sigma is equals to 1. Okay. So, the parameters whatever we consider in the normal distribution as mean mu and the sigma standard deviation both have some particular values. At that particular values, the normal distribution is we are calling as a standard normal distribution. Okay. So, what are that particular values for mean mu and the sigma? The mean mu is 0 and the sigma is 1. So, we got the definition. What is the definition of the standard normal distribution? Normal distribution a normal distribution with the mean mu is equal to 0 and standard deviation sigma is equals to 1 is defined as normal distribution or standard normal distribution. Standard normal distribution. Okay. Standard normal distribution. So, this is the simple definition for the standard normal distribution. Okay. Right. So, what is the density function for the standard normal distribution and what is the standard normal variate? Okay. So, here the standard normal variate is nothing but the variable what we consider in integral minus infinity to infinity 1 by sigma into root 2 pi into e to the power of minus 1 by 2 into x minus mu divided by sigma whole square. In that one, every time when you are solving the problem, you are substituting x minus mu divided by sigma as z. Okay, na? So, that z is nothing but the standard normal variate. Okay, always the normal distribution problems we can transform into the standard normal distribution, then we will solve the problems of normal distribution with the help of the standard normal distribution. Okay, that is the benefit of the standard normal distribution. Why? Because it is not possible to calculate every time the integration. With the help of this standard normal distribution, we have the table values. With the help of the table values, we can easily calculate the probability problems instead of doing every time the integration. Without doing the integration, we can find the probabilities with the help of the standard normal distribution. Okay, that is the benefit. Okay, so the standard normal distribution, their variable is always we denote with z. This z is nothing but x minus mu divided by sigma 0 comma 1, okay, is equals to 1 by sigma into root 2 pi into e power minus 1 by 2 times of, there is no z, x, z square, that's all. Okay, where z lies between minus infinity is less than or equal to z is less than equals to infinity. So this is called the density function of the standard normal distribution, and this z is called the standard normal variate if x is the normal variate, and mu and sigma are the mean and the standard deviation of the normal distribution. Okay, so this is the about the standard normal distribution. What is the shape of the standard normal distribution? There is no change in the shape of the graph of the normal standard normal distribution. It is as it is. Whatever we learn in the normal distribution, all the characteristics of the curve will be same for the standard normal distribution. But when you are drawing the standard normal distribution curve, it will be the peak will be more for this one. Why? Because the sigma is always equals to 1. Okay, that means the distance, this distance is very small. That is, okay, the sigma value is very small. So for the smaller values of sigma, you will get the more closer peaks. Okay, peak you will get like this. For sigma value which are less values. Okay, if the sigma value large, it will expand like this, as usual what we see in the normal distribution curve. Okay, so right, but here this you will get the peak at z is equals to 0. Okay, so and this is a asymptote, this z axis, z is a asymptote to the curve. Okay, I hope it is clear to you. So all the problems of normal distribution problems we can transform into the standard normal distribution. Then we will solve the problems with the help of the table. Okay, so we have the table. The table is prepared for the standard normal variate, that is z. The table is in terms of z you will we have. So that's why every time you have to convert into standard normal variate, then you have to solve the problem. Okay, this is very important concept you have to remember. Now I will explain the areas under the normal curve. How we have to calculate the areas under the normal curve by converting into the standard normal variate. Okay, so how we have to calculate that I am explaining. For example, this is a normal curve. We know this normal curve should be like this. It is asymptote to this x-axis. Okay, there is a peak you will get here. This is x is equals to mu. Okay, so we know the total area under this normal curve is unity. Also we proved. Okay, so that means always whatever values you will get under this curve, all that are the probabilities. Okay, for example, I want to calculate the area of this region. Consider this is the region. I want to calculate this region area. Okay, so the area is nothing but, for example, this is x is equals to x1 and x is equals to x2. What is the meaning of this one? The meaning of that one is probability of x1 is less than equals to x is less than equals to x2 is equals to 1 by sigma into root 2 pi into integral x1 to x2 f of x such that mu comma sigma into dx. So the integration always, we know already the integrations gives the areas. Okay, so if you calculate this one, you will get this region. Okay, so instead of doing the integration for the function f of x comma y, f of x comma mu comma sigma every time, takes so much of time to calculate this integration every time. So that's why we have to convert the given problem into the standard normal variate, so that we have the table values. With the help of the table values, we can easily solve the problem by converting into the standard normal variate. Okay, so how we have to convert into the standard normal variate? So from this graph, I can draw one more line, this one, which is parallel to the x-axis. Just extend this. So always this z is equals to 0. Why? Because that is z is, what is z? z is equals to x minus mu divided by sigma. At x is equals to mu, what is happened? Z is always 0. Sigma is 1. Okay. So the standard normal variate you will get like this. Z is equals to 0 you will get. So this is z is equals to 0. Okay. So what does this indicate? Then this one is, we can write z is equals to x1 minus mu divided by sigma, and this is I want to represent with z1, and this one is z2 is equals to x2 minus mu divided by sigma. Okay. Now by seeing the table, we can easily calculate for the corresponding values of z1 and z2, we can easily calculate the area. Okay. So always observe when you are seeing the table is given for the areas right side of the z is equals to 0 line. Okay. So this is a z is equals to 0 line. I am explaining how we are to see the table. Okay. So if z is equals to 0 line, then the areas in the table are given for this region. That means z is equal to 0 to z is equals to z1. Z is equals to z1. For that values, they given the table values. So the areas whichever given in the table, all are under this region only. This region represents. Okay. Under this normal curve, this region represents the table values. Be careful when you are saying the table. So if the table values are given for this one, then how we can calculate for this? Okay, it is very easy. So I will explain now. First I will calculate z is equals to area from z is equal to 0 to z is equals to z2. That means area I will represent with the capital letter. So if you want to calculate probability of x1 is less than equals to x is less than equals to x2, then I will write this is into standard normal variate like this: x1 minus mu divided by sigma is less than x minus mu divided by sigma is less than or equals to x2 minus mu divided by sigma. Like this I can write. Now I can write the variable z, that is equals to p of z1 is less than equals to z is less than equals to z2. Okay. So if we know the mu and sigma values, we can easily calculate the areas. So for particular values of mu and sigma value, so for the given x1 value and x2 value, we will get easily what is x1 and what is z1 and what is z2. Okay. So with this, if it is z1 and z2, then this area I can find like this. For example, if z is equal to 0 to z is equals to z2, this is the total area. Okay. So this is the total area. If I remove this area, okay, z is equal to 0 to z is equals to z1, if I remove, okay, so if I remove, I will get this region. That means this area minus this plane, whichever is plane, that area if you remove, then you will get this area. That means I can write a of z2 minus a of z1. That means area from z is equal to 0 to z is equals to z2 minus area from z is equal to 0 to z is equal to z1. Okay. So this is the way we can calculate the area under this normal curve. Okay. So now if you want to calculate by seeing for the table purpose, I am explaining everything. So you have to see the table. The table values are given like this. That's why we have to do like this only. Okay. Right. Now I am going to explain what about the area, how we have to calculate the area under the normal curve if the region is like this. If you want to calculate this area, how we have to calculate by using the table. So first of all, every time you have to convert into the standard normal variate. So that standard, now for the standard normal variate, you have to draw, this is a line, z line. So at this line, at x is equals to mu, z is 0. So here you will get one value at x is equals to x1. You have to consider this is z is equals to 0 is here. Okay, so left side of that one you have to consider always z is equals to minus z1. Okay, with a negative symbol you have to write. Right. Then, yeah, this is the area you have to calculate. How we have to calculate? So now I am going to explain how we have to calculate this area. So carefully observe. We know in the normal distribution curve the total area is always 1. That means this line x is equals to mu divides this total area into two equal parts. That means this is 0.5, this is 0.5. Then if it is 0.5, then we can easily calculate this one. How? So the table values are given from z is equal to 0 to z is equal to z1. So you have to calculate the, you have to see the table values from z is equal to 0 to z is equal to z1 only. Why? Because it is symmetric. If you take the area from z is equal to 0 to z is equal to plus z1 is same as z is equal to 0 to z is equal to minus z1. Both are same only. So how we have to calculate areas? Remember, areas we are calculating. That means there is no negative symbol for the areas. Even though if you get the negative, you have to consider it as a positive value. Okay? Why? Because areas does not have the negative values. Okay? So how we can represent this one? If you want to calculate the probability of the meaning of this one is x is less than or equals to x1. Okay, this is the notation for this area, probability of x less than equals to x1. Then this can be written as probability of, if you convert in terms of z is less than equals to z1. Okay, already we know what is z. Z is nothing but x minus mu divided by sigma. Okay, so now this is nothing but, we know this area 0.5. 0.5 minus, if we remove this area, you will get the answer, area of z is equals to z1. I hope it is clear. If we remove this area, x is equals to 0 to z is equal to 0 to z is equals to z1, area if we remove, then you will get this area. Okay, right. So don't consider, when you are calculating area, don't consider the negative symbol. Okay, so just now I explained it is a symmetric. If we calculate the area from z is equal to 0 to z is equals to plus z1 is same area for z is equal to 0 to z is equals to minus z1. That is you have to keep in mind. I hope it is clear. Okay, so like this we can find the area for this region. This is x is equals to mu, corresponding z value is 0. Okay, so wherever you are writing x is equals to mu, the corresponding z value you can write z is equals to 0. Okay, now if you want to calculate this area, that is this area, if you want to calculate, how we have to calculate? Okay, carefully observe here, this area I want to calculate. How we can calculate? So the indication of that area is the probability of x1. This is if you want to consider x is equals to x1, x is equals to x2. So x1 is less than equals to x is less than equals to x2. This area, this probability is nothing but the area under this normal curve, is equals to, can be found by transforming into the standard normal variate. Like this you have to convert every time. This is z is equals to minus z1, this is z is equals to z2. Okay, right. You can, if you want to put, you can put minus z1. No, for this one, okay. Okay, this is just because z is equal to 0 is the left side of 0, that is indicates the left side of z is equals to 0. That's all. Right. Now this is equals to we know the areas from here to here. We know how to calculate. From the table you can directly get the values from z is equal to 0 to z is equal to z2. Okay, z is equal to 0 to z is equal to z2 area we can calculate by using the table directly. So that means area of z is equal to z2 plus this area plus this area. Now already we know that it is a symmetry. Instead of calculating z is equal to minus z1, it is the area is same for z is equal to plus z1. So I am just writing area z is equal to z1. That's all. Okay. Is it clear? Right. With this we can calculate the area under this normal curve for the given region. I hope it is clear. Right. Now the another case, x is equal to mu, the corresponding z value is 0. Right. If you want to calculate this region, so it is very easy. Why? Because all the table values are given for this region only. Okay, from z is equal to 0 to z is equal to z1. This is x is equal to x1. Okay, so no need to modify anything. Just by seeing the table we can write this area. That is, probability of mu is less than or equals to x is less than or equals to x1 is same as probability of 0 is less than or equals to z is less than or equals to z1. Okay, so this is nothing but directly we will get from the table area z1. That's all. Area z1. A of z1 indicates this area. Okay, right. Now if you want to calculate the area under the normal curve for the another region, this is x is equal to mu and this is z is equal to 0. Then if you want to calculate this region, then how we have to? So same, the total area is 1, this area is compulsory 0.5, then we can easily find out this area if you know this area. Okay, so the meaning of that one is probability of, for example, this is x is equal to x1, so corresponding z value is z1. So probability of x1 is less than equals to x is less than equals to infinity, just less than. Okay, no need to put equal. Okay, this is equals to, this is equals to how will write probability of z1 is less than equals to z is less than infinity. Okay, so that is nothing but 0.5 minus total area is 0.5 and we are removing this area, that is area z is equals to z1. From the table you can calculate this. So if you have understood this one, we can easily solve the problems and we can easily understand how we have to check the table values. So with this, the areas under the normal curves topic is completed. Okay, I hope it is clear to you.